Hello, this is Ethan Haley, and I'm here to present my final project for Data 607, which was data acquisition and management. And for my data acquisition for this project, I queried the Spotify REST API, pulled down a bunch of data about playlists. And for the data management portion of it, I used Neo4j, which is a graph database software and server. And my project goals here were from the start of the course, I'd wanted to learn how to build and use Neo4j graph databases. And towards the end of the course, my 15-year-old daughter started clamoring for Spotify, and we already have Amazon Music. So of course I asked her, why do we need something else? It's basically the same 70 million tracks that are available at your fingertips. And she said, it was a one-word answer. She said, playlists. So I come from a different era from her, so I understand what a playlist is, but I didn't understand its pivotal position and how people listen to music nowadays. And up above here, as an example, we can see my Spotify homepage, which has create playlist options over here, my library, which consists of playlists, and down here, a bunch of other playlists for the most part. Some of them I created, like Moon Radio, Pine, and then a bunch of the other ones, these other 5 here, for example, Spotify curated those themselves, and they either suggested them to me or I found them on my own. And this is the way people listen to music now. So I wanted to know, why did my daughter feel it was crucial to pay for a streaming service that has playlists? And to me, it's important to figure out that kind of thing out. And I actually was able to accomplish that in this project, and it was definitely worth investigating and very interesting. So let's go see how you start with this. This is a shot of the sort of a table of contents over on the left here for the REST-based API for Spotify. And my question was where to start within that huge list of options. And I started by getting the 54 playlist genres, since playlists was my guiding light for this project. And with a couple of queries over here, I was able to get those 54 playlists and then start querying by country. So I just did a nested for loop down here for every country, and then for every category, all those 54 categories, get all the playlists that were available on that day, which was, I believe, May 3rd. So this is just a snapshot. This whole project is just a snapshot of what Spotify offered that day. And it would be really interesting to come back and make separate links in all these graphs for as the Spotify playlist change over the days, but definitely outside the scope of this project. So once I had all these playlists, which give you, going back a couple of slides, they give you categories like top lists here returned, and then by country, and then say for top lists for all the countries, there might be 180 or 300 different playlists within that categorization, we'll call it. And so I used a bunch of other code to take all those playlists and then branch out into all the 230,000, I think it was, tracks that were available through those playlists in the various countries. And then on those tracks, I queried beyond that for the artists, and then the genres that the artists were in, and the qualities that Spotify tracks and calculates for all of those tracks. And that includes things like acousticness versus speechiness. So loudness, danceability, entropy. I think they have some pretty strange categories, but a lot of them come down to a way that Spotify can categorize a track in order to be able to recommend others that are similar to the ones that you've liked in the past. And they even keep track of things like the key that the song is in, and then the tempo and the valence, which is a measure of how happy or sad the song is. It's pretty in-depth stuff that they keep track of. And so I gathered all that into separate tables. And it's amazing. They really don't cut you off at any point of this, because they are just interested in getting developers to embed their player inside of whatever app the developer is building. And here's a little chart that shows how global they are over on the far right here, which is pretty recent, the most recent quarter. The different colors that make up that tallest bar there represent the different parts, the regions of the world. You can see it's pretty well split up. So we have Europe is probably the biggest portion down here because that's where Spotify originated. It's a Swedish company. And then North America and Latin America and the rest of the world. And to me, that's important to see that because I like music. I like all kinds of music from all over the world. So I want to see that these musics are being represented. And that's the way the playlists break down is a lot of the music that's on a playlist in a country is from that country. So it's encouraging to see that you can get at your disposal all of these tracks from all over the world that are popular now and that have been popular in these countries in the past. And you can really get a hold of a lot of tunes that you had no idea existed. So it's a lot of fun to use Spotify. Here you can see how the music industry was declining from 20 years ago in terms of revenue. A lot of it was coming from CD sales and albums and so forth. And then this dark blue parts that sort of took over and really saved the industry about 10 years ago is the streaming, which now dominates the proportion of revenue that's coming in from the music industry. And here, this breaks it down by age and gender. I was focusing on the age here specifically since I came at it from the viewpoint of, wow, what's my 15-year-old daughter so interested in this Spotify for? But 55% of the Spotify users are 18 to 34, as opposed to 40% for Apple and 39% for Pandora. And paid users globally, Spotify is crushing their rivals here. They're essentially equaling the total for all the other rivals combined in terms of the number of paid users. So I took all that code that made all those tables. I put it here. I'm not going to go through it, but if you want to take a look at it, I'll include the GitHub link at the end in case you want to get an idea of how to query the Spotify API. And I took all the data frames that I built and essentially built a database with them using the Cypher language on Neo4j. This is about half of the script here. It just shows how you build indexes at the top, much as you would with SQL primary keys. And you're essentially just asserting what has to be a unique ID within each row in each table. There aren't rows and tables in this. It's just one big graph database, but the idea is the same for creating uniqueness in indexes. And then the way I built this was just in chunks here where I started with artists, and then the artist plays a certain genre, and then the genre was listed for each artist in the CSV, the data frames that I'd built. And then from that, you attach all those artists to various other categories and other nodes, which would just be separate tables in a relational database. But in this case, it's just a separate label on a different type of node. And you can take a look at that if you want, but I'm going to move on for now and see what we got out of all that, which was a structure like this. It's just, 8 nodes. And the playlist is sort of central here. It's got connections to 4 other types of nodes. And what can you do with that? Well, let's take a look. Well, first, here's this shows some of the many-to-manyness or one-to-manyness of a lot of these nodes. So for example, 2 different tracks can be on one album, of course, and then one artist can be in 2 separate genres or just in one genre. And then countries and playlists are a N-shaped, so like a many-to-many relationship over here. And you can take a look at this if you really want to know how Spotify structures their database. And before that, let's take a look at what we can do with some of that here. This is the Neo4j browser, which they include as a way to connect to their server that you have your database built on. And I made a bunch of queries here. Probably only have time to take a look at a few of them here. So I started out by trying to figure out where these playlists were playing, like which country they were most popular in. And the type of playlist that shows up in the most countries is chill. So chill shows up in 168 countries, and chill is an umbrella for all the playlists that are categorized as chill playlists. And I scroll down to see some ones that I hadn't seen before, like EDM dance here I was unaware of. And embarrassingly, I had to go look at why Edmonton dance in my mind was popular in 139 countries. Like, who is listening to Edmonton dance? Yes, that's embarrassing. I'm going to go take an inspection of Edmonton dance here. And where is it? It is, here we go. This is all the countries that are playing EDM dance. UK, it's very popular in Netherlands, Ireland. It's a European genre. Turns out it's not Edmonton, it's electronic dance music. And what does it look like? If you want to look at it in the Spotify graph here, let's see what it looks like in Neo4j the way I built it. Well, Edmonton, if you run this query here, I'm sorry, EDM dance, it's going to return the top 100 out of, I think it was 240, but it's preset to limit to 100 results. So if I click on this, I'm going to get 100 playlists that fall under the EDM dance category. And if we zoom out a bit here, you can click on those and say, let's say I want to take a look at, sad beats. Boy, does that sound interesting. So this is a playlist. I'm going to find a bunch of tracks that play on that playlist, or maybe just one or two. Oh, there they are. A whole bunch of them popping up here. And by the time this graph sorts itself out, you're going to see all these tracks, about, well, 99 tracks. You're going to see them circling around this one playlist that I happen to click on. And of course, if you click on all these tracks, you're going to be able to find out, for example, who the artist is and a bunch of the features that relate to that track. Well, it's going to show the album it's on here. The artist is apparently Griffin. Griffin, by these incoming arrows here, you can see all these other tracks that Griffin recorded that are on this same playlist, Sad Beats. And you can keep digging down and checking out the relationships as you want, which is part of the fun of this graph database structure. So I'm going to move on. I only have a couple minutes left here probably, so I just want to see some of the other things I looked at here were let's see. I want to see the median date of all these tracks, 230,000 tracks or so. And the median date was about 2 years and 3 months, which is actually a lot older than I expected. And I took a look at which keys are the most common here. And the most common keys for the 230,000 tracks are C major, G major, D major. No surprises to the musicians out there. Those are pretty common and easy to play tracks, especially on keys, especially on a piano. And down at the bottom of the list, we see a lot more of the minor keys, which are not as popular. No one likes to be sad when they're listening to some of this music. And then up here we have, these are some of I sorted the playlist by by the variety of key signatures that were in it. And depending on how you look at it, got some sort of interesting results, but it's just an idea of the kind of thing you can do with this sort of structure. And then I wanted to see which countries are playing the less popular music. Where is that music more popular? Well, Algeria and Bulgaria for starters. This is the poppiness factor. That was the average popularity of the songs that were in the playlist in that country. And who's playing the most popular? Romania. Well, this is actually just the 50th one. So up here, I went to the other countries that are playing the more popular music, and it turned out it was a lot in the Caribbean for some reason. So I guess my theory would be that if you're relying on tourism, you're going to just play popular music. Just a theory. So my last thing I wanted to look at here was something I found interesting. I wanted to look at putting in two artists that I liked that were disparate. They just came from different genres and eras. So I used Thelonious Monk, a jazz musician from the middle of the last century, and then I used Eminem, so a rapper from the turn of the century. And I put those two artists in at the end of this M here. I wanted to find out a middle artist that I might like, maybe that I haven't discovered or listened to before, and really everything else in between that connects them. So Thelonious Monk played a track that's in a playlist that contains another track by some mystery artist that I should discover, who played another track in a different playlist that includes a track by Eminem. So let's just see what that actually returns. And here's what I got out of it. Was the Black Eyed Peas are the other artist that is that mystery artist connecting Thelonious Monk and Eminem. And what's interesting with this, and I think so useful about a graph database, is I can see Thelonious Monk over here, and I can see in an instant that there's only one playlist connecting him to the rest of the M, if you will. And between the Black Eyed Peas and Eminem, there are tons of playlists, there are tons of tracks, but there's just this one connecting one here, which looks like it's either probably, I was gonna say Chinese, but it's probably Japanese. I don't think China actually has Spotify. I could be wrong, but this looks like a Japanese playlist that includes the Thelonious Monk and the Black Eyed Peas. So maybe I'll go check that out. Maybe that playlist has some interesting tracks, or maybe the Black Eyed Peas are just a good place to start. But maybe Spotify uses this kind of relationship when it's trying to recommend tracks to users based on other artists that they like or other tracks they've listened to. And so I just want to go back to a quick concluding slide here and say that I had a lot of fun learning about Neo4j and Spotify in this project. And I hope it was fun for you guys to watch this. And what I'd like to do in the future is to go back and explore the user created playlists on Spotify, because what we just looked at was the Spotify created playlist. This is what they're spoon feeding to their users. And that accounts for about a third of their global daily listens, by the way. The user created playlists account for another third. And then the third is just random clicks by users on something that piqued their interest at the moment. And looking at user created playlists would definitely involve a lot of getting permissions and a lot of red tape like that. But the payoff would be that you'd be able to build, perhaps in Neo4j, a really cool graph that represented a social network where people were suggesting to their friends what to listen to. And that's really, in my case, my daughter's case, that's why she is interested in the playlist on Spotify. She's not interested in what Spotify has to recommend to her. She's interested in what her friends are listening to. And that would make for some really interesting investigation in a future project. Thank you.